Alright, let's do this. Okay, hope you all did good on the exam. Get things set up here. Okay, let's do this. We got an abbreviated lecture today. Only got an hour, so let's get to it. We just obviously had the midterm. You're all well aware of that. Now we want to talk about files and exceptions and how to test methods that read files. All this getting you ready for task 6. So I want to make sure I get all my task 6. Everything you need for task 6 has to happen in 1 hour. Let's go. So we're reading 3 different files for task 6. You're going to write 3 methods, one for each file type, file format, and also some testing. Let's do it. Testing, so we have to test methods that read files. So we have to write methods that read files, test methods that read files. That's our agenda for the day. And as we do, we're going to go to live coding. If you open the stream early, you saw me setting up this example. Let's do this. And I want to delete this one, actually. Are we going to have time to do that whole thing? Yeah, I want to do live coding, so let's do it. Let me just delete the guts of it. I want to do live coding, so let's code at least one test case. I'll just walk through a lot of the code that's here because again, it's an abbreviated lecture. I would like to live code every piece of this, but I mean, we're just going to run out of time if I do that. Midterm submissions are over now. Yes. Yep, midterm's done. If you submit now, it's considered late. It's not going to count. So, yeah, I mean, the exam's over. It's pencils down. Okay. So, and I put the end time 3 times in my email. There should be no confusion on that one either. So let's go over the code that we have and the task at hand. Then I'm going to write a test case, and then we'll write the code. If you're watching the 8 a.m. and the 11 a.m., I'm going in a little different order in the 11 a.m. When can we expect grades for the midterm? Goodness, I've had 1 minute and I have a lecture to do. Cut me some slack here. No, valid question, though. So I always hold myself to grading, giving myself a 1-week deadline for grading. I don't think that's fair in the summer. Usually it's 1 week because that's how long you have to do things. Since the expected deadlines are 2 days, I'm going to give myself 48 hours from for the exam. I'm going to try to get them all done tonight, but I don't know if I'll have the energy to do it, but I'll get them done tomorrow. But I got to hit the expected deadline. 48 hours from the beginning of the 8 a.m. exam. So Thursday, 8 a.m. is my deadline for myself. So what we want to do is write this method, this load countries method. It's going to take a file name as a string and return this hash map of string of array list of cities. We'll get to what all that means. But first, I want to talk about the file format that we're going to use. And it's this, a CSV file in this format, country, city name, region, population, latitude, longitude. This is our goal for today, is parsing CSV data, which is all 3 file formats for task 6. It's all CSV. So let's learn how to do CSV. And this is the file that I'm going to use for today's lecture. I'm going to, actually I want to delete this also. I want to, never mind, I won't. So this is the format. It's country code. It's going to be a 2-digit country code. Then the name of a city, a 2-digit region, which is a string. Even though most of them are integers, they're going to be handled as strings. The population as an int, and then latitude and longitude as doubles. This is the format that we want to handle. And what we want to do with this is return a hash map of strings, which will be the countries. I want to return a hash map that's going to give me the cities for each country. So the strings, the keys are going to be the country codes, those 2-character country codes. And they're going to map to an array list of all of the cities from that country. This is our goal. This is what we're doing for the next hour, is building up to this. So we'll set that aside for now. Let's talk about what the city object is. And it's a straightforward object. I know there's a lot of code on screen, but at this point you should be you should be able to look at this and see what's going on here. It is a container. The city class is a container for 3 strings, the name, region, and country, which intentionally mirrors your song class. That's just 3 strings. But we also have an integer for the population and the location as a location object, which is 2 doubles, latitude and longitude. In both classes, it's going to be off topic for lecture. I'll glance at it when I get a chance, so let me explain this first. The 2 classes have getters for each of the instance variables and a constructor which will initialize the instance variables, and no setters. So same with the city. City, we have 3 strings in the constructor, the int population, and the location object for latitude and longitude. Getters for all of those instance variables, and then city also has a 2-string just because it can be useful at times to print as a string. So that's the city class that we're working with. We want to return a hash map of strings, the countries, to an array list of those cities with all of the proper data. And we want to talk about how to test that. I'll leave this code on screen while I parse this thing. Hey Jesse, this is more of a Piazza post, but I think I saw something about it for the effort points. Would I need to pass both of the OP and data tracing? So I need to get all 4 correct to get 2. I mean, this is in the syllabus too. Yeah, it's more of a Piazza question, but I mean, that's in the syllabus. We went over it day 1. And for the midterm, you have 4 traces. Each one's worth an application objective. I don't think I call them effort points this semester, right? Yeah, we don't have effort points, but each one's worth an application objective. It's just a straight 1 for 1. You get 1 of the traces on the midterm, you get an application objective, you get 2, you get 2, you get 3, you get 3, you get 4, you get 4. So what I want to do is set up some utility methods first. And I'm seeing a lot of this in office hours in Piazza. So I don't know how much this will apply to everyone who comes to lecture regularly and watches the lectures. But it was, the syllabus had hard wording. Yeah, it's a lot to explain because I'm trying to explain the learning objectives and the application objectives in the syllabus. So yeah, I get that. It does get convoluted. But the application objective part of it, if you just read that in isolation, the application objective part is straightforward. On the midterm, it's just 1 for 1. And then the final, you don't get any application objectives. But then when I'm also explaining all the learning objectives, I'm like, well, you need 1 from each category. The categories are OP and data structures. That one does get convoluted. So they kind of get mixed up. But yeah, I get that. And I'm always looking for better ways to word that. I'm still missing a little bit. So I want some helper methods that are going to my utility methods. I see this in office hours in Piazza where students will have issues that are directly caused by not using the utility methods. The assignments are structured in a way that I have you write the utility method to help you write your tests, so your tests are a lot easier to write. So if you ignore the utility methods, if you treat that as, okay, I had to write this utility method, now I have to write tests, and treat them as completely separate things and not the utility method building up to your testing, you're going to have a worse time. That's how you miss things like checking the reviewer ID when a reviewer rates a song. That's one of the most common issues. Or for linked lists for task 3, not checking all of the ratings and not checking everything with all the ratings. If you just use your utility method, you cannot make mistakes like that. You won't make mistakes like that, and you'll save yourself a lot of time in the long run. But it does take a little bit to set up using the utility methods. I think that's where a lot of students get hung up, is they sometimes just don't know how to use the utility methods. So I do want to talk about that a little bit. But the utility methods themselves, let's go over what these ones are. Compare cities, takes 2 cities and asserts, fails an assert if they're not the same. This is just like your compare songs, compare movies, compare, I don't think I ever had you write a compare movies, did I? Compare linked lists of review or ratings. Any of the compare methods, compare reviewer, compare rating. Any of those compare methods, same idea. We're taking 2 city objects and we want to know if all of their instance variables have the same values. So I'm asserting all of the instance variables, making sure they're all the same. And then for my hash maps, I'm going to use this as a helper method to compare 2 hash maps. I have my expected hash map. This is what I've forcefully created. There will be, we'll write this test case, is what I'll forcefully create and set to exactly what I do expect. And then the actual, this is what I actually got from the method call. This is what the method returned. So I have the task to compare two hash maps to make sure that they have all of the same values. And when I'm comparing two data structures like this, the first thing I always like to do is check their sizes. Are they the same size? If they're not the same size, we're done here. So I'm going to assert that they're the same size, make sure that's true. And then moving forward, I know that they are the same size, because if they weren't the same size, this assert would have failed and the whole test would be over. So now I know they're the same size. So what I want to know is, does actual contain all of the same information as expected? So I'm going to go through the keys of expected and make sure that that key exists in the hash map of what I'm testing. If that key does exist, then I'm going to get the values for both expected and actual. I'm going to get the array list of cities. The value is an array list of cities in this case. Get that array list of cities for each. And then I have, again, the situation where I'm comparing two data structures. I'm going to make sure they're the same size. And then if they're the same size, we'll get to this loop where I'm going to go index by index, just like you did for the cast lists for movies. I'm going to go index by index and make sure that the values at each index are the same using my compare cities helper method. And I want to take, I promise we'll get to file IO, but I want to take a little bit of a departure, mostly so I don't forget to do this, because hash maps are a lot different than array lists. And on your homework, you have the situation where you're going to have to compare two array lists, either of songs or movies, for the same values. Do these two array lists contain all the same movies? Do these two array lists contain all the same songs? Where the order doesn't matter. So my correct solution in Autolab can return the songs or movies in any order in that array list, and you have to take this unknown entity, this unknown array list, and make sure it has all of the songs that you expect, or movies. I'll just say songs, so it's simpler to say. All of the songs that you expect, but they could appear in any possible order. So this is different than any array list comparison we've done so far, where usually your array list comparison, you're going index by index like we just did with cities. You go index by index and check, are the values at index 0 the same, are the values at index 1 the same, etc. And checking pairwise comparisons. Now we have to do something a little bit different. And if you go into week 6 lecture coding bank tests, this is the an example that honestly is way too much of a hint for, basically does the testing for you, the utility methods. But I want to show you this because it can be a pretty big hang up if you don't see the strategy right away, so I'm just going to give you the strategy. This is an example that I don't have time to do in the summer, but usually is in week 6, which that week just doesn't exist in the summer because there's no time. But at week 6 is usually testing tips and tricks. There's no new concepts covered, but there's a lot of things that can give you some help with testing. And this is one of them. This is the most important in terms of task 6 at least. This is taking two array lists of bank accounts and checking if they are the same, if they contain the same information, but in any order. So I can't go pairwise by index. I have to check for the expected bank accounts in the actual in any order. So I'm going to do the same thing we did before. First thing is check to see if they are the same size. You can do your null checks. I added this, I don't know, just because I wanted to at some point. But the, or maybe Paul even added that. But I won't have, unless it's linked lists or trees, I'm not going to have any test cases that are going to throw null inputs at you. It's just not a game we play in 116. But where it's linked lists and trees where null actually has meaning, we'll mess around with null. But if it doesn't have meaning in those two cases, any other situation, we're not going to throw null at you. Or else you'll just have to have null checks everywhere and it kind of gets tedious. So we're going to check if they're the same size. If they're the same size, I'm going to go through all of the values in my expected. I'm going to go through my expected bank accounts. And for each expected bank account, I need to go through the entire actual. I'm going to get the values out of the actual and make sure that this expected account is somewhere in the actual array list. But I can't just assert. I can't just go through the actual and assert, are these bank accounts equal? Are these bank accounts equal? Are these bank accounts equal? Because all but one of them, if actual is correct, all but one of them are going to be this expected account. So all but one of those asserts are going to fail. So we can't quite do that. But what I can do is use a flag. I generally don't like Boolean flags like this, but this is a situation where it's just called for. It's the answer. Is we're going to set up a flag that's going to keep track of whether or not we found the value we're looking for. And I'm going to go through all of the bank accounts in my actual and check if that bank account is the bank account I'm looking for. So I'm checking both. It's got two instance variables in this case. This is where you would do call your song, compare songs, helper method, compare linked lists of ratings. This is where you call your other utility methods to check, are these two songs, are these two movies the same? Are these what I'm looking for? And if they are, if it's like, okay, I got my song or I got my movie, then it's exactly what I expected, then we're going to say, found it. We found it. And then after this loop executes, after we checked all of the values in actual, then we're going to make sure, we're going to assert that we found what we were looking for. Because if we made it through all of actual and didn't find what we were looking for, then this is going to fail because there was an expected account that we didn't find. Fail the test. But we want to make sure we get this assert in there somewhere because we want to make sure that we account for that. Hey, we didn't find what we're looking for. We didn't find all of the expected values. Let's get out of here and fail this test. And this, of course, would be replaced with your song, checking your song. Oh, I just said that, didn't I? Checking your songs, checking your movies. But this is an approach you can use. You can borrow this approach. This is in the repo. It's covered in lecture. You can even just borrow this code and replace bank account with song or movie. And then here, change these checks. Instead of checking bank account stuff, check song and movie stuff. Okay, got that out of the way. That's one of your big hints for test 6. Test 6 testing and testing utility methods. You're only asked to write one of the utility methods, but it's going to really help you to write both of them for songs and movies. Okay, so that's what we're doing here. We have our utility method set up. Now it's time to write a test. We're going to ignore the second test for now and write a test for this cities data. So we got the cities.csv data. I have a header line, so it's important to note the data I'm working with has a header line. You have to pay attention to whether it has a header line or doesn't. And then I have all of this data. All of this data. I'm not going to scroll through it all. I'm just going to jump to the bottom here, which is minus the header line, 47,977 cities across many, many different countries. So when I'm testing this, let me get the order the way I want it. So when I'm testing this, what I'd have to do, let's start writing some code now finally. My file name equals, and your file name is always relative to the root directory of the project. So starting at the root directory, follow the directories, and that's data/cities.csv. So data/cities.csv, which is the same structure as in your project. That's given to you in the project. You have the data directory with just movies.csv. You can download the other two files from the handout and get the song data and the movie ratings also. But make sure you put them in this data folder with all 4 lowercase letters. It's in the handout just because I've had students in the past name this with a capital D and waste hours of their life. I don't like seeing that. So I seeded it with the movies.csv to get the directory structure proper so nobody has to go through that again. So data/cities.csv. And then I'm going to call my method that I'm testing, which is countries example week 10 lecture dot load countries of file name, and that's going to return a hash map of string to array list of cities. and that's going to be my actual. This is what I actually got from the method that I'm testing. And now I need to set up my expected. I'm going to run into a real big issue right away here. Is I need to do expected.put and go to my data. Let's go back to the, oh, I am back at the top. And we have to get all of the data in this file. So let's look at our first country, AD. So I'm going to go put AD mapping to a new array list of arrays dot as list new city, and I'm going to add these cities to my file. So let's get this here. The country, okay, so the city, I gotta be careful with my constructor order here. Name, region, country. Name. I already forgot. Name, region, country. Region is 04. Regions are strings. Where did I even type that? 04. Country is AD. Population is 7211. And I have to use my location class, new location of 4255, 1.51, etc. Okay, that's the first city. And then I'm going to need the second city. And we're already running into a pretty big problem here. Is there's no friggin' way I am going to do this and code all of this data, almost 48,000 cities into my test case. So I need to put all 48,000 cities into my test case and hard code my expected. And this is how you, well, not this exactly, but this is how you should set up your utility methods. You get your actual, and then you hard code your expected to exactly what you expect the method to return. And then in the end here, we're going to call compare country hash maps, expected actual, and the utility method does everything else for us. Everything else is done for us, because we already wrote it in the utility method. Don't duplicate your work. That's what I see a lot of students doing, is duplicating your work. The only thing you should be doing in your test cases is grabbing whatever the method you're testing returns, setting up what you expect it to return, then call your utility method, and the utility method does the rest. That's what you should set up for each test case. We like each test case to be simple to write. We want to be able to write it quickly. Okay, but that's not what we can do. We can't do that here because we got to code up 48,000 cities, and I'm never going to do that. So the answer to this is don't use the full cities.csv. Don't use the full file for testing. That's insanity. You're never going to write effective tests that way. Nobody's going to code all these up. And anybody who uses the full data file, what they end up doing is taking shortcuts everywhere. What I see a lot of students do is use like songs.csv and then check, get the actual, and just make sure actual is the right size and make sure it's the size they expect. That's not testing. You can have all of the completely wrong data in there, or you can have absolutely no ratings in any of those songs and still pass that test case. You have completely ass code that'll pass that test. We don't want to do that. We set up these utility methods. We want to use them because the utility method tests and checks absolutely everything with every object in every array list. That's what we want to do. So what we do is set up a testing file. I'm going to take a subset of the data, a subset that is still properly formatted. So for my format here, I have a header line, so I'm going to make sure I grab the header line, and then create a testing file that is just that data that I'm testing. And I like to start off with the simplest test case I can. In this situation, it's just one single city. And I'm putting that in cities test 1. So when I go to my testing, instead of testing with cities.csv, I'm going to do cities test 1.csv. So I'm going to use this trim down file. Now my expected is actually everything that I want it to be. It has just that one city in it, one country mapping to the one city that's in that country in this test file. Now I'm looking good. Now I can run this. It's not going to pass because we haven't written any actual code yet, but I can actually complete the test. Like, this is a 100% great functional test. It's more of a sanity check because it's only one city. My code can be horribly wrong and this will pass. But it's a good, proper test case. And then I won't have you sit through the torture of having me just cut and paste city data for a larger test case. But we eventually want larger test cases. So I have this cities test 2, which is testing more of the complex behavior of my method. I'm making sure I'm at least getting one country with multiple cities in it, while also having multiple countries. So I have 2 countries, and one of those countries has 3 cities. This is like a bare minimum, more complex test case for your songs and movies, making sure you have a song that's rated more than one time, a movie that's rated more than one time, multiple movies, multiple songs, etc. But you do want to create your test files. So like when you're testing with songs, just grab a couple songs, make sure you have at least one song being rated multiple times, and set up your test files that way. Put all your test files in your data directory in your project, and then Autolab knows what to do. It'll look for that data directory and preserve all those files while it runs your tests. And for movies, I've seen a lot of test cases with Toy Story and Jumanji, what I expect at this point. But spoilers, what I'm about to say. Take just a few movies, put them in your test file, and what I see is a lot of students will take just a couple movies, put them in their test file, and that's great. That's exactly what I just said to do. But you can also take it a step further. Like, if you can handle a couple cast members, you can handle a whole mess of them. So instead of putting yourself through the torture of taking all of these cast members and putting them in an array list for your cast, cut this down a bit. You can cut this down to, let's cut it down to 3 cast members. It's a lot easier to code up when you're setting up your array list. And for this one, let's cut it all the way down to, down to 2. And make sure you have different size cast lists. Make sure your code isn't hard-coded to expect 2 or 3 cast members. Make sure you vary it up a little bit. But you don't have to put the whole cast. Like, there's a certain point where you're getting diminishing returns on your tests. If you can handle 3 cast members, you can probably handle 100. Like, it'd be a weird bug in your code. For out there in the real world testing, you probably want that test case with 100 cast members. Make sure you're not breaking once things get really big. But we don't have to add too much tedium to this. And then same thing for your songs. Get your smaller test files, and that's going to make your testing a lot easier. And then use your utility methods. Make sure you're getting 100%. I'm in the wrong file here. Make sure you're getting 100% testing on your tests. Or else, people, not just students, people will get lazy. They'll check, okay, do I have a key of GI? And does GI map to an array list of size 1? If so, I'm good. Maybe also check the name of that city. Is the name Gibraltar? Okay, yeah, we're good. Without ever checking region, country, population, location. Do I have a key AE? Does that map to an array list of size 3? Okay, we good then. Call it a day. It's good. It's fine. But here, no, we're testing everything. We're getting the actual. We have our trimmed down testing file, so we can hard code expected. It's still a little bit of tedium, but not that much, and it's well worth it to have a test case that's rock solid. This test case is absolutely making sure everything is correct. And I'm coding up those 4 lines from the file, getting all those cities, and then throwing it into my utility method. So we have our tests. We can run all of them. They're all going to get null pointer exceptions. And now we're ready to write some damn code. So we want to write some code, and I'm going to start with a helper method. Array list, which is going to, the ID is going to ruin one of my surprises here, but that's fine. I want to write a helper method that's just going to read a file, because we have the situation where we're reading these CSV files like we had to do for task 6. We're doing in this example here. We're going to have a lot of situations where we take a file name as a string and we just want to read the file. So let's set this up so that we're reading all of the lines of a file. So I want to get an array list of string, which is going to give me the lines, I don't even call it of the file, equals something that we're going to return. Lines, plural, semicolon. So let's learn how to read a file in Java. Ooh. Okay, so what we're going to do is call a couple of methods. Files dot read all lines. If you look up how to read files in Java, they're not going to show you this method. At least last time I checked, this was pretty well buried, and it's not. Let me get it on screen first, and then I'll explain it. But this is the way I recommend doing it in 116. This is going to be great for 116. We're going to do files.readAllLines. If we look at the signature of this method, it takes a path object. And we don't have a path object, we have a string. So this is going to, as the name implies, read all the lines of the file. But it needs a path, and we have a string. So we have to do one extra step. Paths.get is going to take a string and turn it into a path. So I'm going to do paths.get of my file name. This is going to convert my string into a path. Here's the documentation for you if you want it. It's going to convert my string to a path, which means it will interpret that string as a path on your file system. It's going to treat slashes as moving into subdirectories. It's going to treat a leading slash as your root directory, things like that. And it's going to get that path, parse the string and get the path information out of it, which is what readAllLines needs. So readAllLines will take a path, navigate that to that path in your directory structure on your hard drive, and then read that file that it's given. So we do have two separate steps, and both get and readAllLines are both static methods. So I'm importing the paths class and calling the get static method from the paths class, so from the class.get, and files readAllLines is also a static method. So from the files class, I'm calling the readAllLines static method. So I'm calling two static methods from two different classes to get the job done of reading this file. And I forgot that I don't have the slides to help me, so I forgot this. But why even read files at all? Why are we even messing with files at all? Which might seem like a silly question. Like we even as a non-programmer, you know about files. You use files all the time. So it seems kind of silly on the surface, but just a reminder, they should have covered this in 115, I'm sure they did. But just a refresher, we use files for persistent storage. That's the key, that's why we use them, is persistent storage. So everything we talked about so far in 116 has been in memory. It's on the stack, it's on the heap, we trace the memory diagrams and everything. All of that is in memory, meaning it's on your RAM sticks. And memory is temporary. As soon as your program ends, all memory is freed up, the stack is gone, the main method stack frame is gone. Like you actually cross out the stack, you know all the stack's gone, but also the heap is all freed up as well. Once the program ends, the operating system comes back and reclaims all that heap space and everything's gone. There's no trace of your program ever running left in memory. And likewise, when your program first begins, memory is a clean slate. There's nothing. We want data that persists after our program ends or exists before our program begins. We're going to need to go to the hard drive. So we'll have to go to disk, which is files. So that's why we read files. We save data in files, so it persists longer than the life of our program, which is called persistent storage. Even throughout a shutdown, you shut down the machine entirely, your hard drive remains, memory is wiped. So that's the big difference, is our persistent storage. And we want lots of data too, lots of data that exists before our program starts. That's what we're doing in 116. We're not going to save files. Maybe someday we'll start doing that. But we will read files that already exist, that have persisted before our program starts. So we can load all this data into memory and then start working with it. Okay, so this code is going to read all the lines of that file and then return those lines as an array list of string, where the string, where each element in the array list is a separate line in the file. That's what we have here. Except there's one big problem. The ID, the slides, I can hide this and be all coy about it. The ID is giving me this big scary red underline and says, you can't do that. And if I try to run this code, it's going to say, nah, you can't do that. That's not allowed. What are you, insane? So what do I do? Unhandle exception, IO exception. Okay, let's talk about exceptions. So the issue is that read all lines is going to throw an exception, but the underlying issue here is that we don't know if that file's going to exist. If that file doesn't exist, read all lines is going to throw an IO exception. We'll talk about that in a second. But there's no possible way we can guarantee that this file exists when we read it. Now we can check. You might say, well, let's just check. Which is, I don't know why I said it like that. It's a really reasonable thing to say. We have this method exists, which takes a path. So let's do paths.get file name. And we'll say if the file exists, read it. If it doesn't exist, just return a new array list. We'll return an empty array list. This is a very reasonable thing to do. We're checking if it exists. If the file exists, read it. If it doesn't exist, just give me an empty array list. Cool. But I still have an error. The problem, and this is a pretty nuanced point, I always try to keep this short. I said in the earlier lecture that I'd keep this short, and then I still talked about it for a while. But then somebody asked a question about it, so maybe I should just explain it, because it's a weird thing. But this doesn't work. The problem here is that we're messing with the disk at this point. We're going to the hard drive. And the hard drive, our files, are shared among all programs running on our machine. All processes can access the file system. Whereas everything up until this point was all in memory, and memory is isolated for your program. You have 100% control over memory, the memory that's been allocated to your program. You're the only one allowed to touch it. Even the operating system isn't going to mess with your memory that's already been allocated to your program. That's your memory. Nobody else can touch it. Not true with files. Anybody can mess with these files, which means somebody can, say, delete that file. Another program on your device might delete that file. And it can happen that happens right in between these calls. So after you check, after this method call resolves and you check, okay, the file exists, it's there, we're good to go. Between that point in time and the call to read all lines, there is a finite amount of time. It's a very small window, but there's a finite amount of time that passes between those two method calls, and the file might be deleted in between those two calls. And if it is, you're screwed. And the file's not there, and the file that you literally just checked if it existed might not exist by the time you get to the next line of code. It can happen, and it does happen. Now you might think, oh man, that's got to be ridiculously rare. That'd be dumb for that to happen. That's never going to happen. But the bigger issue here is that you could potentially, and I say potentially, but this happens, this can happen, is that you have another process on your device, on your machine that's running, that reacts to this check. It sees that you touched that file, and as soon as you touch that file to check if it exists, it reacts to that and then deletes the file. Now, hopefully you don't have a program that's just deleting every file that's touched, that's looked at, that's checked, but it could possibly happen that it's deleting it. Or more likely it might be writing or reading that file or writing to that file in reaction to the check if it exists, and then as you're reading it, the file is being modified, which is going to also cause some issues for you. So it's the reaction to this. Even though the window's tiny, you might have the exact circumstances where the program's reacting to your check and exactly going in that window of opportunity for it to mess up your code. And I had I'll keep the story short, but I had a student had all kinds of issues with their IntelliJ. Whenever they would type some code and the code would just disappear. They'd type it again, it would just disappear. They just couldn't get any code to stick in their program. And what was happening, after much investigating, it took a long time to find out what was going on here. What was happening is that they had OneDrive installed on their machine, and OneDrive was noticing the file change. As soon as they changed the file, OneDrive was like, whoa, something happened here. And it would go to the server and say, hey, your file on disk is different than the file I have saved on the server, so I'm going to overwrite your file with the file that's saved on the server. Now, I don't know why OneDrive did this, probably because Microsoft just loves making our lives more difficult. Is that, or they're just incompetent? I still can't figure out which one it is. Probably, I'm leaning towards incompetence, though. I don't know. Let's not go down that road. No, not time for that rant. But anyway, OneDrive was messing up their code and constantly overwriting it from the saved version on the server because they were backing up their directory for their files on OneDrive, which is a reasonable thing to do, to back up your code for a course and have a history of all the changes and stuff. It's a good idea. But OneDrive disagreed, and OneDrive was constantly overwriting their changes. So if you have something like OneDrive that's saying, whoa, that file just changed because maybe when this exists, I don't know exactly how this works, but maybe exists will change a timestamp on that file saying that it was read or something, and then decides to delete it and say, hey, thanks for reminding me that that file exists. By the way, that file doesn't exist on the server, so I'm going to delete it for you. And then all of a sudden your file's not here on the very next line of code, and you go nuts trying to debug it. So this doesn't work. All that to say, this doesn't work. We cannot guarantee the file is going to be there. We can't guarantee it. We just can't do it. So instead, what we're going to do is catch the exception. We're going to change our if-else to try catch. And we're going to catch that IO exception if it's thrown. So instead of just running this code, we're going to try to run it. And if this throws an IO exception, if this throws an IO exception, then we're going to catch it and run this code instead. So we're going to run this code, and if an exception is thrown, we stop running this code entirely and switch execution over to the catch block. And I missed one thing. Read all lines returns a list or something that implements the list interface, which I believe is actually an array list in this point for read all lines, but that's besides the point. That's a topic for Thursday. We'll talk about interfaces and implementing interfaces and stuff. For our purposes right now, if you don't want to think about lists, and I'll say this again later in the lecture for arrays, if you don't want to think about lists, stuff your list into the array list constructor and just use array lists. And you don't have to think about what a list is or polymorphism. It has to do with polymorphism. We'll learn about it next time. But maybe not in the context of list itself, unless I have time to give that example. But just stuff it into the array list constructor, and that still is just because that was an error. So this is still an error, still the uncaught exception error. The error just changed when we switch it to a try catch block the first time. So if this throws an exception, we're going to catch it. Now exceptions are thrown regularly. Is that fair to say? You've seen exceptions before. For example, a null pointer exception, that's an exception that's thrown. And if an exception is thrown and not caught, then it's going to crash the program. This is a special one. The IO exception is a special exception where if you don't catch it, your code just doesn't compile. Like, you don't have the opportunity to have the program crash with an IO exception. It just has to be caught. It's a little bit of a lie, but I don't like showing you there's another way to do this without try catch. It involves writing some code right here. Don't do that. Do not do that. I'm not going to show you the syntax. I'm not going to show it to you anywhere in lecture. If I ever see that in office hours or Piazza, I know you didn't get it from me, and I pretty much can guarantee you didn't write that code. Usually, that's students who use the auto, fix it for me. When they get that red underline, they say, IntelliJ, write my code for me. Don't be doing that. Just don't do that. Write your own code. Do your own homework. But if you are doing that, you'll get the other thing, which doesn't work in general, but doesn't work in Autolab either. That's why it's always an office hour Piazza question, because it doesn't work. And every time I'm like, you didn't write that code. And they're like, yeah, you're right, I didn't. Just follow a lecture, this is probably preaching to the choir situation here, but use the try catch block, try to run this code. If it throws the exception, catch it. You can also catch other exceptions, so an alternate way to do your null pointer checks in your tests is to catch that null pointer exception. You can catch that and then, do your thing. If it's a test case, maybe just fail for that. And you can have multiple catch blocks for different types of exceptions, but if an exception is thrown and there's no matching catch block for that specific exception, your program is going to crash. That exception is going to bubble up and crash the program. When that happens, when your program does crash from an uncaught exception, you get your stack trace, which tells you every single stack frame that was on the stack and the line number where that stack frame was executing at that point in time. And that's all that red text that's printed when your program crashes. You get all that red text. That's your stack trace. Everything that was happening in stack memory at that point in time. Not everything, it doesn't show you all the variables, but it shows you all of the method calls for every stack frame. So it gives you an idea of where you were, what was happening when that program crashed. And then you click on the top or bottom, I forget which one, the blue links, and that's going to take you right to the line of code that threw the exception, and you can start debugging from there. Okay. But this is good. Read file. That's it. That's saying variable's redundant. We could just return right away. We don't have to store this in a variable, but I felt like it. Okay, so if the file exists, we read all the lines. If it doesn't exist, we return a new array list, and you're welcome to just copy this code and use it in your project to read files in Java. That's reading files in Java. And we got 12 minutes to write load countries. We're doing all right. So let's use that and load these countries. So we're going to need a hash map of country codes to array lists of cities. Where is that read file code? If you go just to week 10 countries example, this is the version that's already written. This is the one that'll stay in the repo. It's right here. So I'm basically just recreating the code as usual for these lectures. I'm just recreating the code that's already there. I'm not going to push this code to the repo, but you can use the one that's already there. And you can get a foreshadow of what I'm about to type too. I'm about to do this. It'll probably look a little different because I'm live coding it. So let me create the hash map that I'm going to return. And return it. We'll get rid of that null pointer exception already. And then everything in between that is where I want to um, populate this hash map. So first I'm going to load the file, load read, I called it read file name. I didn't make this static. This should be static. So task 6 is the only time, unless I'm forgetting something, should be the only time that static methods make a big return. Aside from your midterm, you had a few static methods, just because I didn't want to force you to put this on every single stack frame. Like when you're traversing the tree, if you had to put this in every stack frame, it's just tedious. But if you did, that's one of the things where if you have this in every stack frame, I don't know what reference you would even put there, but that's going to be considered a minor mistake anyway. Because most of my stack traces in lecture had, it doesn't matter. So I have my array list of strings. It does matter, but I don't have time to go on some tangent right now. So I'm going to get all my strings. So I'm going to use my helper method here, read all the lines of the file, and then iterate over all the lines. And for each line in the file, here's where I want to do my CSV stuff. Oh, yeah, I got to explain CSV parsing. 9 minutes. We got this. So what I want to do is read all the portions of this line. And at this point, I like to grab a test line from the file. Whenever I'm parsing information from a file, just a me thing, I guess, but I'm going to grab a line from the file and use that as a reference just so I know what I'm supposed to be looking at. I also I usually leave this as a surprise, my stuff actually failed and everything, but I'm just going to have this handled right here is if the line equals the header line, I'm going to ignore that line. I'm going to use the keyword continue for that. What continue means, if I can spell it right, what continue means is advance to the end of the loop. Skip the rest of this loop and then go to the next iteration of it. Alternatively, I could do an else, or there's other ways to set it up, but I want to show you continue at some point. There's also break, which just ends the loop. Whatever's happening just loops over. Okay, so I need to parse this CSV information, and I'm going to show you this one. Regrettably, I'm going to show you the wrong way to parse CSV. We're going to take the line and split it on commas. So what this is going to do is return an array that has all the values of the line separated by commas. So if this were my line, split on comma is going to return an array with the values country, city, region, population, latitude, and longitude all as strings. And I did say array, not array list, but just to keep the number of data structures down, I want to just talk about array lists. So we're going to stuff this into the array list constructor. You're welcome to use arrays. If you just want to work with the plain old arrays, the syntax is very much like lists in Python. So you're welcome to do that. In lecture, I'm going to just show array list so we can focus on just one data structure, not get bogged down with array list, list, and array. We don't really need 3 data structures for that. So array list, and then we do have to convert the array into a list. So our good old friend arrays.asList is going to come in handy. And so arrays.asList converts the array to a list, and then the array list constructor takes a list. So we can split by commas and get all of our information into an array list. That's not the right way. Oh yeah, that's not the right way to parse CSV files. For example, if your data contains a comma, you're going to split your data in half. If population had a comma in it, that's just wrong. But if population had a comma in it, then that value is going to be split in 2 pieces. So if your data itself contains a comma, the right thing to do is escape it with quotes. So any value surrounded by double quotes, you should ignore any commas in it. That's a part of the value, a not a separator of data. And if you need a double quote and a comma, you have to escape the double quotes. So this is popu, comma, la, double quote, shun, all is one single value. And parsing all that would just be extra tedium that has nothing to do with the learning objectives of CSE116. And unlike Python, Java doesn't have a built-in CSV parsing library, and any third-party CSV parsing libraries I've looked at are way convoluted and way harder to use than they need to be. So we're just sticking with this. So string, country, which all the data, the movie, song, country, city, all this data that we're working with in 116 has been sanitized. None of the values contain commas or double quotes, so we don't have to worry about it. In the real world, please don't just split on commas. Use a library to parse your stuff for you, to parse your CSV. Okay, so let's get all of the data out of this. So we got our array list, and we have our data. We know the first value is the country code. Next is the city name. 1, 2, 3, 4. So the value index 0, 1, 2 is going to be the region. Value index 3 is going to be the population. And here we come up to a sticky situation. Population should be treated as an int, and our lat long should be treated as doubles. So we need to do something else here, and if we want to convert a string into an int or a double, we have a few methods. Integer dot value of. Why doesn't it like that? Integer, oh, sorry, parse int. Parse int, oops, oopsie. Integer dot parse int and double dot parse double. These are static methods in the integer and double classes, respectively. These are going to convert your string to a double or an int if the string is well formed. So as long as these values are well formed, which all the data I'm going to give you will be well formed, you have to convert your ratings into integers. This is the way to do it. But if your value isn't well formed, so if like this is your string, this is going to give you a number format exception. And if that exception isn't caught, which there's no reason to catch that for our purposes anyway, then it's going to crash the program. So that always means if you have a number format exception on task 6, that means you're trying to parse something as an int that isn't an actual int. You grabbed the wrong value, you either got the wrong index here, or something else went wrong. You're reading the wrong file, parsing songs, but you gave it movies, something happened, something went wrong. Then we want to create our city object. So city equals new city. And I want to make sure I get my constructor order correct. When you're creating songs, especially you have 3 strings, no compiler is going to tell you that you got the order wrong. You have to make sure you got the order right. Name, region, country. So city name, region, country, population, new location, latitude, longitude. So that's my city. And now comes the last thing, important thing we're going to get in the last 2 minutes here. Might go a little over, but worth it. We need this for task 6. Is we want to add this city into our country hash map. And there's one big question we have to ask ourselves before we do that is, have we seen this country before? So I'm going to write some code that checks, have I ever seen this country before? And that's going to be if my country's hash map contains the key countries that contains the key of this country. Load countries. Oh my goodness. Autocomplete doesn't always do what you want. You gotta only use it. Only use it if it's typing exactly what you would have typed, or I would have had some major issues there. So if I've never seen this country before is the question I'm asking. If the country's hash map does not contain this country as a key, then I know I've never seen this country before. And this is the way I like to handle this situation is if I haven't seen this country before, I'm going to what we call lazily initialize it. So I'm going to say countries dot put country. I'll fix that issue in a minute. And then new array list of cities. I don't have to say of cities, but what? It's because I missed an N here. Ugh, that's what's causing me all my headaches. So if I've never seen this country before, I'm going to initialize that country. And whether I've seen this country for the first time or not, unconditionally, so I'm not putting this in an else, I'm going to say countries dot get my array list at that country and then add this city to it. So for your homework, this will be either songs or movies. You're going to say, have I seen this song before? If I've seen this song before, that means I already created the song object and I just want to add the rating to it. And, oh, thank you, return to. I want to add this rating to it, but if I've never seen this song before, I want to create a new song object. And what I recommend for the homework for songs and countries is creating this hash map, because the hash map just makes this so much easier to do. As with this example, you can still use a hash map. There's no hash map required, but you can still create one. Create a hash map of strings where your strings are the song IDs or the movie titles, or the song titles, I suppose. I make sure the song titles are unique in the test cases. A hash map of titles to song or movie. You don't have to have a sub array list like this. So map a song's ID to the song for that ID, and then check, does my hash map contain a key for that song, this song's ID? If it does, just take this rating and add it to the existing song. But if this is the very first time I've ever seen this song, then create the new song object with this artist title and song ID and a new linked list. Well, it'll create the linked list of null for you. But if I have seen the song before, just add the rating to it and move on. Same with movies. When you're doing movie ratings, have I seen this movie before? If so, just add the rating to it. If not, or rather, let me say it the way I have the code. If I've never seen this movie before, a movie with this title before, initialize the movie, create the new movie object, and then just add the rating to that movie or song. Okay, we got there. A little bit over, but with only having 1 hour, I'm used to having 2.5 hours. Getting that in 1 hour feels nice, or is good getting it in. So test pass, I always like to see my test fail. So let's just break the test itself. So just to make sure that we are actually testing something, and then fix it, see our test pass. So we are handling these situations perfectly fine. All right, I'll have office hours still today at 2 o'clock. I'll get the midterms graded. Good luck on task 6 and the rest of the course. Hopefully you all did great on the midterm. Hopefully we'll see some good results there. And have a nice day. Take care.